Hello, my name is Rafael Diniz. I work at Rhizomatica, and today I'm going to present you our new modem that's meant for transmitting data over HF for very long distance stations. And this is our demonstration today. The name of this modem is called Mercury, and it will be used today to transmit data between this radio to this radio. It's a simple demonstration that we use dummy loads. Later on, I will show a demonstration from radios that are far apart. So for today's demonstration, this radio will transmit data to this radio. This is a watt meter connected to the transmitting radio. It's putting out around 6 watts of power, right? And these here in the back are the dummy loads that are really radiating. These are radiating the power to this one that is connected to the receiving radio. Okay. This is a S-bit-X radio that we use in Rhizomatica in our project called Hermes. That's high frequency emergency and rural multimedia exchange system that's being deployed in Bangladesh, in Brazil, and also in Africa and Central African Republic, okay, for connecting communities isolated to the telecommunication world, right? So here Mercury is in action. I will show you briefly the screen here, and later on I will show the capture of the screen. So here the first line is the transmitting side. Here's the modem. The modem is set now in the mode of the config 13. In our website, you can see the configuration. Basically, configuration 13, we are putting out around 2.5 kilobit per second of data. Here in the second window of the transmitter, we are transmitting a text file, a book, War and Peace, that has 3.3 megabytes, right? And the second line is the receiver side. Here we have some information of the receiver, like the signal to noise radio, the actual data of the frame in hexadecimal. Here in the second window of the receiver, we have the actual frames being received by this sample software that just gets the data and writes in a text file. And here I'm just printing what is being received live from this software. And this is the text of the book being received right now from this radio to this radio with Mercury at around 2.5 kilobits per second. Okay. So here I'm showing the capture of the screen of the Hermes transmitter in the first line and the Hermes receiver in the second line. So here is Mercury modem running config 13 at 2.5 kilobit per second. This is the sample software that connects to the Mercury modem, and in this case we are transmitting a file, a TXT file of 2.3 megabytes. It's a long one, so it will take a long time, so this is why I'm using it. And the second line here is the receiver. So here in the first window is Mercury modem receiving the data. Here is our sample software which connects to the modem and gets the data from the modem, writes to a file. And this is just the file being read in real time, and it's being printed to the screen. And that's our modem being tested on the air on dummy loads in this setup. Okay. So if we stop transmission, of course the receiver stops receiving it. Here I'll show the wave showing up in GQRX. It's a simple this is a simple software for receiving the airwaves on Linux. I'm using SDR called AirSpy Plus HF, AirSpy HF Plus Discovery, and this is a USB dongle that I just connect in my computer, and here we can see the signal over the air, and here's the actual data being transmitted in the first line and received in the second line. Mercury, the sample software, and the text also being shown here. And here's the wave. Let's turn it off. And it's off. Turn it on. And it's on again. Thank you very much, and this video will follow by another one with over-the-air tests